Good day, guys. This is Mr. Prince, Maths and Science class, and in this video, I'm going to be solving some questions on kinematics. In the first question, we have that a car accelerates from rest at 2 meters per second squared for 10 seconds, then continues at constant velocity for 20 seconds. Now we say we should find the total distance traveled. So whenever I'm doing kinematics questions like this, like I said in the video I uploaded before this, I talked about the four kinematic equations. But before you can be able to figure it out, you need to write out the terms, the parameters you are given in the question. So it says the acceleration, it starts from rest. So if it starts from rest, that means the initial velocity, which I represent as u, will be 0 meters per second. So whenever you have it a kinematic question that it says an object starts from rest, that means the initial velocity is 0. And it says the acceleration is 2 meters per second squared. Okay, so I got that through the SI unit, meter per second squared for acceleration. And it says the car accelerates from rest at 2 meters per second squared for 10 seconds. So the time is 10 seconds. Okay, and it says it continues at constant velocity for 20 seconds. So if I wanted to draw the time graph, it will look like this. Let me draw the distance time graph. So we have meter per second squared, and this is seconds, right? So it accelerates from rest at 2 meters per second squared. This is 2 meters per second squared for 10 seconds. This is 10 seconds. So it's constant velocity. It's like this. It's going straight. It then continues at constant velocity for 20 seconds. It says, what is the total distance traveled? So now for us to get the final velocity, we are going to use the formula V is equals to U plus AT. Okay, so the final velocity is not given. The initial velocity is 0, acceleration is 2, the time is 10. Okay, so V is equals to 20 meters per second. 2 times 10 is 20. So now we want to find the distance during acceleration. So find the distance during acceleration. We are going to find the distance during acceleration, and we'll find the distance at constant speed. Okay, so that will be S. We are going to use the formula S is equals to UT plus 1 over 2 AT squared. This is the formula we are going to use to find the distance, because we are given initial velocity, we are given the time, we are given the acceleration. So this one fits. So I will name this one S1. So S1 is equals to 0 times 10 plus 1 over 2. The acceleration is times 2. The time is 10 seconds times 10 squared. Okay, so this one will be equals to 0 plus 2 with the cross out 2. So that's 10 squared, or 10 times 10 is 100. Okay, so that will be equals to 100 meters. Okay, so if we want to find the distance at constant speed, so that will be this one. Okay, so anytime for example, if we have to find the area under the time graph, is similar to you finding the distance at constant speed. If you look at this shape from here to here, that's a square. Okay, so that's a square. We have it the entire length is 20 seconds. Okay, 20, and this side will be 22. So this is like a square. So the formula for the area of a square is L squared, right? So that'll be 20 times 20, which will give us 400 meters. Or we can just multiply the velocity by the time. So S2 is equals to velocity times time is equals to 20 times 20. That's the final velocity times the time in 20 seconds. So that will be 400 meters. Okay. And if we want to find the total distance will be equals to S1 plus S2. Okay. So that will be 100 meters plus 400 meters. So that will give us 500 meters. So this is the total distance traveled. So now the next question says, a car moving at 25 meters per second comes to rest in 5 seconds. Find 1, acceleration, and 2, find the distance traveled. Okay, so if I wanted to do this, I would let me draw the distance time graph. So it's gonna look so like this. So it's starting. So we have velocity meter per second, right? We can call this velocity time graph too. So it's moving at 25, comes to rest. Okay, at 25 meters per second. Okay, and within 5 seconds, this is time. So this place is 25. That's the peak of its acceleration, and it starts from 0. Okay. So if I wanted to find the acceleration, we are given the initial velocity to be 25 meters per second. So now because it is coming to rest, the final velocity will be equals to 0 meters per second. Okay. So we are given the time to be 5 seconds. So for us to find the acceleration will be A is equals to V minus U over T. This is the formula for acceleration. So the final velocity is 0, initial is 25, and the time is 5 seconds, right? So we will have minus 25 divided by 5 will give us minus 5 meters per second square. So because it's starting from an initial velocity and is going to rest, that means the car is decelerating. Okay. So now let's find distance. Now I want to find the distance now. This is part 2, find the distance. So if we want to find distance, we're going to use the formula S is equals to UT plus half AT squared. And the reason is that we are given the initial velocity, we are given the time, and we are given the acceleration. So if we wanted to find distance, this will be the best formula to use. Okay. So we have S is equals to 25 times 5 plus 1 over 2 times the acceleration is minus 5 times the time is 5 squared. Okay, so 25 times 5 is 125 plus 1 over 2. 5 times 5 is 25 times minus 5 is minus 1 times minus 125. Okay, so that will be equals to 125. 120 minus 125 divided by 2 will be minus 62.5. So that will be equals to 62.5 meters. Okay. So that will be the distance traveled for the car. So the next question says, a ball is thrown upward at 20 meters per second squared. Find the maximum height and the total time in air. So in this case, at the maximum height, the final velocity will be equals to 0. V equals to 0. Okay. And then U, because the ball is thrown upwards, the initial velocity will be 20 meters per second squared. Okay. So now, for us to find the maximum height, we are going to use the formula V squared is equals to U squared plus 2AS. And because this ball thrown upward, this question is quite similar to the question of a projectile motion. So we're going to use acceleration due to gravity, and we know that acceleration due to gravity is 9.8 meters per second squared. Okay, so that will be 0 squared is equals to 20 squared plus 2 times the acceleration due to gravity will be minus 9.8, and we are looking for s, that's the distance. So 0 equals to 20 squared, 20 times 20 is 400, plus 2 times minus 9.8, it will be minus 19.6 s. So the distance will be equals to 400 divided by 19.6. 400 divided by 19.6 is equals to 20.4 meters. Okay, so now I want to find the total time in here. If we want to find the total time in here, we are going to use the formula v is equals to u plus at. Okay, so we know that the final velocity is 0, the initial velocity is 20, right? And the acceleration is minus 9.8 times t. So let's carry 20 to the other side, becomes minus 20. We have minus 9.8 t. So this minus will cross at each other. Okay, sorry. So t will be equals to 20 divided by 9.8. 20 divided by 9.8 will give us 2.04 seconds. But you need to know that for us to get the total time taken, it will be 2 times of the time. So big T is equals to 2 times of the time. So that will be equals to 2 times 2.04. That will be equals to 4.08 seconds. So this is the total time taken. So the next question says 2 cars start from the same point. Car A 10 meters per second constant, while car B start from rest, accelerates at 2 meters per second square. So it says, when does car B catch car A? Okay, so we are going to use distance equation. So now for car A, the distance equation, we have SA, this is distance for car A, will be equals to velocity times time. Okay, so the velocity for car A is 10 meters per second, so that will be SA is equals to 10t. Okay, now for car B, so car B start from rest, so we will say that the initial velocity is 0 meters per second square. I want to write out all the parameters. The acceleration is accelerated at 2 meters per second square. Okay, so we are given those two, but we are not given the final velocity. So now we are going to, the formula we are going to use is the distance formula we are going to use for kinematic, among the kinematic equation for car B will be ut plus 1 over 2 at squared, because we're already given the acceleration, we are given the initial velocity, and we don't have the time. So the initial velocity is 0 times t plus 1 over 2, acceleration is 2, times t squared. Okay, so that will be equals to, this will be 0, so 1 over 2 and 2t squared, these two will cross at each other, so that will be equals to t squared. Okay, so now that we have the distance for car A to be 10t, okay, and we have the distance for car B, SB is equals to t squared. So now we are going to equate these two together. Okay, we equated these two together so that we can know when both of these cars will catch up with each other. Okay, so we set it together. If we equate it to each other, that will be t squared is equals to 10t. Okay, so if we take 10t to the other side, it becomes a quadratic equation. So that will be t squared minus 10t is equals to 0. So t you can divide through. So t squared divided by t is t, minus 10t divided by t is minus 10 equals 0. So because it will not be t is equals to 10 or t is equals to 0, but because the t cannot be 0 seconds, so therefore the time that these two cars will catch up with each other will be equals to 10 seconds. Okay, so now the last question for this video says a car accelerates at 4 meters per second squared for 5 seconds, then decelerates at 2 meters per second squared until it stops. Find the total distance traveled. So I want to draw the distance time graph, or velocity time graph, whatever you call it. So we have meters per second squared here. We have the time t. So it accelerates at 4 meters per second squared. Okay, so this is 4 meters per second squared for 5 seconds. This is 5 seconds. And then it decelerates at 2 meters per second until it stops. Okay, so I can just put it this side as 2. Okay, so now we're going to let me write out the parameters. So the initial velocity is 0. Okay, because it starts from rest, and the acceleration is 4 meters per second squared, and the time it takes for it to get for it to accelerate is 5 seconds. Okay, so now we're going to first calculate velocity after first phase. Velocity after the first phase. So now this formula we're going to use, since we're given the initial velocity, the acceleration and time, the best equation that matches it is v is equals to u plus at. Okay, in this case we'll be able to get the final velocity. So v is equals to initial velocity 0 plus 4 times 5. Okay, so that will be equals to 20 meters per second. So now we are going to find the distance in the first phase. Okay, so we'll find distance in the first phase while it was accelerating. So we have S1 will be equals to ut plus 1 over 2 at squared. Okay, so we have it that the initial velocity is 0, right? So 0 times, and it's 5 seconds that it took for it to accelerate, plus 1 over 2 times 4 times 5 squared. Okay, so this will be 0 plus 2 divided by 4 is 2. 4 divided by 2 is 2 times 2 times 25. That's 2 times 25, right? So that will be equals to 50 meters. Sorry. So now we are going to calculate now the distance while the car was decelerating. Okay, distance during deceleration when the car was trying to stop. So we're going to use the formula v squared is equals to u squared plus 2as. Okay, so we know that the because now it starts, now we are starting this is another phase of the journey for the car, right, while it is decelerating. So the initial velocity will be the continuation of where it was accelerating from. So we know that the final velocity from the acceleration was 20 meters per second. So it's going to, since the car is continuing on the same journey, but now it is decelerating, now u now will be 20 meters per second. That's going to be the initial velocity while the car is decelerating. Okay, and then the final velocity, since it's going to rest now, it will be 0 meters per second. And the acceleration from the acceleration while it was decelerating, the deceleration was 2 meters per second. So that will be negative 2 meters per second squared. Okay, so now the best formula to use is v squared equals to u squared plus 2as. because this is what we are given, because now we are trying to find this one s. Okay, so that will be 0 squared is equals to 20 squared plus 2 times minus 2, okay, s2. So that will be 0 is equals to 400. 2 times minus 2 is minus 4 s2. Okay, so s2 will be equals to 400 divided by 4. That will give us 100 meters. So now to get the total distance traveled by this car during the acceleration and deceleration, so total distance will be equals to s1 plus s2. So that will be equals to 50 meters plus 100 meters. So that will be equals to 150 meters. So that will be all for this video. So anytime you are given a question, kinematic question, make sure you take note of when the question says that the car or the object starts from rest, or maybe it's accelerating and then it went to rest. So that helps you to know the final velocity and the initial velocity. And it's always important for you to write out all the parameters first, because when you write out all the parameters that is given in the question, now you are able to know the right equation to use. Because most students, they get confused with on how to use the right kinematic equation to use for every question. You write out the parameters first, and it gives you a better view. And if you need to draw the velocity time graph or distance time graph to understand the question better, make sure you do that. And I hope you enjoyed the video. Make sure you like, comment, and make sure you subscribe to the channel if you've not. Thank you.